we're going to do here in R is create some data where we know the population parameters, sample from that data, and then see if sampling gives us an answer that's approximate to the population parameter that we're interested in. So it's really something, this exercise is really just to show you that sampling can get us approximately to the correct answer. So what I'm going to do here is on R, I'm going to define this object called population, and it says see sequence of 1 to 100. What this is going to tell R to do is create this object called population here, and this object is going to be the sequence of numbers from 1 to 100. So when I type in population here, what do we get? We get the sequence of numbers from 1, 2, 3, 4, 5, all the way to 100. So this is going to be our population, right? And so this is just an example, and here we have a population of 100 because it's manageable, it's small. And what we can do here is we can find the mean of the population, and it's 50.5, as you would expect. So here we have a population, and the population parameter that we're interested in would be the mean, and we can see that we know with certainty that the mean is 50.5 because we've created the population. Now what we're going to do is use a function called sample that's pre-programmed in R, and what sample does is it'll take a random sample of draws from an object, and in this case the object is the population. So what we're going to do here is create a new object called S1. It's going to be a sample from the population, and that population again is the sequence of numbers from 1 to 100, and we're going to take a sample size of 20. 20 for no reason, just that's a random number I picked. So if we look at what sample we get from 20 draws from this population, we get the numbers 95, 75, 45, 44, 3, 50, 84, 99, and so on. So it's a random draw of numbers from this pool of numbers, right? We can calculate the mean from this sample. So what's the mean of S1? And it's 44.7. And so it's off, right? The population mean is 50.5. The sample we drew is 44.7. So the mean here is off by a bit, you know. So let's see what happens when we take another sample. So what this is doing is defining an object S2, and it's going to be a sample from the same population, a sampling with replacement. You can read about in the book what that means. And the size again is going to be 20. We type in S2, and we see that S2 is a different sample than S1. It's the numbers 51, 73, 85, 45, 56, 89, and so on, all from this population here. We could type in what the mean of S2, this second sample, is, and it's 63.85. So we overshot it by quite a bit in this example. So what we can see here, right, from these two samples is that no sample is a 100% accurate depiction of the population. Samples, a single sample, can be wrong, right? Can give you an incorrect estimate of the population parameter. So let's look at here when we draw a third sample and type in S3. Here we get a different set of numbers from sample 1 and sample 2. Right? They both drew 51, but then we see 62, 24, 15, 88, 30, 97. So some of the same numbers have been drawn, some different ones. And if we calculate the mean of S3, we get the mean of 56.1, right? Which again overshoots the 50.5 true population mean. Now let's do this for sample 4. Take another sample, and this time we'll just see the mean is 46. Let's do another sample, sample 5. This time the mean is 44.85. So none of these samples have given us a mean that's near the population parameter of interest of 50.5. They've all been over or under. But what we can do is if we take the average of these samples, right, which I'm doing here, what's the mean of sample 1 plus the mean of sample 2, the mean of sample 3, the mean of sample 4, the mean of sample 5 divided by 5, we get 51.5, right? And that's much closer to the population mean. So this is what Chapter 6 is trying to demonstrate to you, is that, you know, you take one sample, and that's going to be in the ballpark of the population mean, but it's not going to be exact. But if we were to take a collection of samples from that population and sample again and again and again, eventually as we increase the number of samples we take, we're going to get something that approximately gets closer to the true population mean. So we'll talk about sampling distributions in a separate video.